Hello everyone. In this video, I am going to explain the operation of buck-boost converter. The buck-boost converter is another type of DC to DC converter. We can use it for both step up and step down the DC voltages. In previous two videos, I discussed about the operation of buck converter and also boost converter. Buck converter is used to step down the voltage and boost converter is used to step up the voltage. From this buck boost converter, we can do the both the tasks, step up and step down both the tasks. Assume you have a variable power supply, it assume it will change at 24 volt and 29 volt, and our application is works at 26 volt. Then assume if the supply voltage is 24, we have to step up the voltage up to 26 volt. Then we need the boost operation. And if the supply voltage is 29, we need the buck operation to get the 26 volt for the application. Then this kind of converter is used for that kind of application to step up and step down the voltage. And if we consider the basic circuit arrangement, this is the basic circuit diagram. Here we have one diode, switching element, inductor, and one capacitor. The elements are similar to the converter and the boost converter, but the arrangement is different. Then we can discuss the operation of switch on and switch off times. And this Q is act as an active switch. We can operate it with higher frequency value based on our application, and this diode is act as a passive switch. It will on or off based on the voltage is applied to this anode and cathode. Now let's move to the operation of switch on and switch off. If the switch is on, switch means this Q, this path is closed, and if we consider this loop, this will be the closed loop, and positive voltage is applied to that point. If we consider this diode, this is the cathode of the diode. Then positive voltage is applied to the cathode of the diode. Then this diode is in reverse bias mode. Then this one is set as a open circuit. Then there are no any closed path to this side to the capacitor and resistor, and the current will flow through in this way through the inductor. Then inductor is start charging. That means it's stored energy from the input supply, and inductor current will increase due to the supply voltage. And if we consider this point A and this point B, and if we consider the polarity of this voltage, we can mention plus and minus is appear here, and this is the inductor voltage VL, it is equal to VAB, and the Total supply voltage is applied to the inductor if the switching loss are 0. Then we can neglect that switching loss. Then we can write VL is equal to Vs. It is the supply voltage is directly applied to the inductor. That is the operation during the Q is on. Then we have to consider the Q is off. If Q is off, now we have stored energy in this inductor. Previously, this is the sign plus and minus. Now, inductor start release its energy. Release its stored energy. Now signs are changed to plus and minus. Now, if we consider this diode, the negative voltage is applied to the cathode side, and with respect to that, the positive voltage is applied to the anode side. Then diode is act as it is acting forward bias mode. Then we can see there's a closed path through inductor, through the load, and through the diode. This one is open circuit. And if we consider the current path, we can draw like this. This is the current path. Inductor releases its energy through this path. And if we consider the output voltage, positive voltage is applied to that point and negative voltage is applied to that point. And if we consider the point A and B, I previously draw that A and B in here. If we measure the VAB, you can see it will be a negative voltage because the sign at the point A is negative. And this VAB is directly applied to the output. I will write that VAB is equal to Vout, but VAB is minus value. And VAB is our inductor voltage. And from that one, we can write VL is equal to minus Vout. And that is the operation during the Q is off. Now we have to derive the output voltage equation and graph for each and every parameters. If we consider the operation of Q during turn on and off, this is the graph for operation of the switch. This time is Ts, this time is Ts. And if we consider the inductor current, now I consider this operation is continuous conduction mode. That means inductor current will not goes to 0. During the turn on time, IL is increased from a minimum value IL min to IL max. And during turn off time, inductor release its energy, then it is go back to the IL min. That is the inductor current graph. And If we consider the diode current during turn on time, diode is reverse bias, then there are no any current flowing through the diode, then current through the diode is 0, and during turn off time, the total current flowing through the inductor will go through the diode. Then we can draw similar graph for turn off period, this kind of graph. Then input current during turn on time, inductor is charging from the supply, then I in is equal to the inductor current. The shape is similar to the inductor current, and during turn off time, I in is 0 because this part is open circuit. There are no any current flowing through the this switch. Then during off period it will be 0. This time is dps and this ts. If we consider the inductor voltage during turn on time, we can write inductor voltage is equal to supply voltage Vs. It is a positive value Vs, and during turn off time we can write VL is equal to minus Vout. We are getting minus voltage at the output end, minus Vout during the off time. This is on off. And if we consider V out graph during turn on time, there are no any voltages appear here from this side, and we can draw 0 volt. And during turn off time, minus VAB is appear here, that means minus VL. Minus VL, that means negative voltage is applied to this output end. Now we can derive the output voltage equation from the supply voltage. For that one, we can use this equation delta IL is equal to VL delta T over L. We are using this equation for previous two videos also. And from the current balance equation, we can write delta IL on plus delta IL of is equal to 0. From this equation, we can get the output voltage equation. For Q on, we can write delta IL on is equal to VL is during turn on time, VL is equal to Vs, and delta T is dTs over inductor value, it is L. And if we consider the off time, delta IL off is equal to during turn off time, VL is equal to minus V out, and delta T, Ts minus dTs, Ts minus dTs over inductor value L. For that one, we can rearrange V out times 1 minus d Ts over L. Then we can equal these two to that equation. Delta IL on plus delta IL off is equal to 0. Delta IL on is equal to Vs times dTs over L plus delta L of is equal to minus V out 1 minus d Ts over L is equal to 0. If we consider this equation, we can cancel this Ts and L. Both are common for both the terms. Then we can write d times Vs minus V out 1 minus d is equal to 0. Vs into d is equal to V out 1 minus d. From this one, we can write V out is equal to d over 1 minus d time Vs. This is the equation for output voltage of a buck boost converter. If we consider the value of d, it is always less than 1. And for this buck boost converter, we have to consider two ranges. D is less than 0.5, d over 1 minus d. If we consider this part, the d value is less than 0.5. Assume I consider 0.4 as example. 0.4 over 1 minus d. 1 minus d is 1 minus 0.4. It is equal to 0.4 over 1 minus 0.4 is 0.6. It is equal to 2 over 3. This value is less than 1. For this condition, V out is less than Vs. If the d value is less than 0.5, this is act as buck converter. Voltage is step down. Now we can consider d is greater than 0.5, d over 1 minus d, 0, assume I consider 0.7 as example, then 0.7, 1 minus 0.7. For the numerator 0.7, denominator 1 minus 0.7 means 0.3. It is equal to 7 over 3. It is greater than the 1. Then V out is greater than supply voltage. Then for this condition, it is act as a boost converter. If the value of D is greater than 0.5, the converter is act as a boost converter. If the D value is less than 0.5, it is act as a buck converter. D value is greater than 0 and less than 0.5. That is buck operation, and D value is less than 1 and greater than 0.5. That is the boost operation. And that is the main operation of the buck boost converter. And these are the graph. And this is the method how we are getting the output voltage. I hope you got clear idea about the operation of buck boost converter and derive the output equation. Thank you.